In this lecture, we're going to try out inheritance for the first time in this course. But before we do that, let's remind ourselves of what inheritance really is. Inheritance is a feature we have in C++ to be able to build new classes in terms of the classes we have predefined. And the new classes are going to be stealing features from the already pre-existing classes, if I can say it like that. And the more classes we build in terms of others, we're going to end up with what we call an inheritance tree, which is basically going to go from the top to the bottom with the most fundamental class on top and a derived class at the bottom. Here we have a simple example. For example, we can have a person class, and this class may be defining the basic features of a person. But based on that person class, we might want to derive other classes that build on top of this person class. For example, we might want to define an engineer and a doctor. And we know that an engineer is also a person, so they are going to inherit some features from the person class. The same goes for the doctor class. It is going to inherit some features from person, but all these derived classes are also going to add their own features to the person class. C++ allows us to build these kinds of relationships. Here is another simple example. We have a vehicle class to the top of our inheritance hierarchy, and below this class, we might derive a truck class, which is also a vehicle. We might have a minivan, we might have a truck, we might have a pickup truck. We may really do all kinds of crazy vehicles, which are going to inherit the basic features from the vehicle class and add their own specialization on top of the vehicle class. So this is the basic idea behind inheritance in C++. So the examples we're going to do in this lecture. So here is a simple example of what we're going to do in this lecture. We're going to set up a person class, which is going to be our base class. It is going to be defining two member variables, which are going to be of std string type. We're going to have a last name for the person and a first name for the person. We are going to derive from this class and set up a player class. The player class is going to inherit these features from the person class, so it is going to have a last name and a first name built into it, but that's going to be our base or our starting point. We are going to add to this base and add another member variable from player, and we're going to be having a player class, which is really a person, but it is going to add things to person to customize on what we can do with a player that we wouldn't originally be able to do or have with a person class. This is the basic idea. Okay, now that we know this, we're going to set up our person class, which is going to be our base class. It is going to have our two member variables, first name and last name. We're going to have a bunch of constructors, and we're going to have a stream output operator to be able to print this on the console and see our information here. Nothing special. But now that this class is done, we can build other classes on top of this class. So what we can do, for example, we can derive a player class. So the syntax is what you see here. We say class player, we say colon, and then we say public and specify the class that we are inheriting from. So the parent class for this class is going to be person, or in other words, we're going to be deriving from the person class, and we're going to be doing that publicly. Okay, for now, I don't want you to worry too much about this public keyword. We're going to be learning this in steps. Just know that this is the syntax you use to derive from another class. Now, the moment we do this, the player class is going to have the person information embedded inside, but we will also have the ability to customize or add other things at the level of the player class. This is what we do. We have a private member variable, and it is going to specify the game the player plays. We're going to have our own set of constructors. We can really build player objects, but they are going to have a person part inside that is going to store information about this player person. You notice we don't have a member variable here for the first name. We don't have a member variable here for the last name, but that information is going to be baked into this player object. And this is really how inheritance helps us out. We can derive from classes and build on top of them without having to redo the fundamental work to build our base classes. We can just build on top of them and really do things faster and more efficiently. Okay, so here are a few things you need to know about the public inheritance that we just did. And we are saying public inheritance because of the syntax we used here. Public person. This is doing public inheritance, and we're going to see what this gives us. So with public inheritance, derived classes can access and use public members of the base class, but the derived class can't directly access private members from the base class. I want you to let this sink in. What this means, from the player class, we can't directly access the private member variables we had in person. Remember, our first name and last name are private to person, and we can't directly access them in any deriving class that is doing public inheritance. Okay, so in our player class, if we try to access the first name and the last name, we're going to have compiler errors because we can't directly access them. But not to worry here, we can still go through the public getters that we have in the person class to access the private member variables from the base class. And that's what we're going to do in this lecture here. Because we don't have access to more powerful tools, we're going to learn about in the next few lectures. The same is also going to apply to friends of the derived class. They are going to have access to private members of the derived class, but they don't have access to the private members of the base class. If you try to access the private parts of a base class from a friend of the derived class, you're going to have a bunch of compiler errors. Okay, now that you know this, we're going to head over to Visual Studio Code and play with this a little more and really drive this home. Here we are in our working folder. The current project is First Try on Inheritance. We're going to grab our template files and put them in place. Let's do this. And we are going to open this in Visual Studio Code pretty quick by dragging and dropping here. Let's do that properly. And we're going to have our main CPP file. We can clean this up a little bit. And we're going to add our classes. The first class we're going to add is the person class. So we are going to create its header file. And let's do the CPP file. I am going to grab the code I have lying on my drive for the header here. I am going to put the class in. We are including the classes we're going to need. We need string and IOStream here because we're going to be outputting things through the output stream operator. And down here we have our two member variables. We have first name and last name. They are of std string type. And we have a bunch of constructors here, a default constructor and one that takes two parameters. We are taking them by copy here. This is bad. We should at least pass them by reference here. Let's correct this pretty fast. And we're going to make the second one a reference as well. Let's do this. And we have a destructor which is going to do nothing because we really aren't doing any dynamic memory allocation here. We're going to head over to the CPP file and put in the code for that. We're going to include the person and we're going to do our constructors, put in the implementations, I should say, and we're going to pass our parameters by reference again. Let's do this. And our constructor should be done now. We have a person class that we can use to derive other classes and use this class as a foundation to build other classes. To visualize this again, our class person is going to be the base class for our player class. So if we build a player class, it's going to have a person part of it, which is going to be the foundation on top of which we're going to build. Notice that in player, we don't need to set up last name and first name. They are going to come from our person part of player. All we need to do in player is set up the game member variable to make him a full player who can have the game they happen to be playing. This is the idea here. Okay, so now that we know this, we're going to put in our player class. We're going to create the files for it. Let's do player.h. We're going to put this in, and we're going to do player.cpp. We're going to put him in. We are going to hop over to the header file and put in our code. The class is going to be player, and it is going to be inheriting from person. This is the syntax. Again, we say colon, we say the kind of inheritance we want to do. In this case, it is public. And then we say the class that we are going to be inheriting from. From this point on, the player class is going to have a person part of it. And we are going to prove this in a minute when we run this code here. Notice that we can build player objects by just passing in the game parameter here, which is going to be used to initialize our member variable. Let's also make it a reference because this is good practice. It is going to avoid copies. You can even use string views, but that's going to be your choice. We are going to hop over to the CPP file and put in our implementation. And this is going to complete our setup for the player class, which is going to be inheriting from our person class here. We can actually head over to the main CPP file and include the player class. Let's do this. We're going to say player, and we can create player objects. Let's look at the code again. For a player, we have a constructor, which is going to take a string parameter. We can use this to create a player and specify the game they are going to be playing. But for now, we don't have enough tools to put in the data that would initialize the member variables in the base class, which is person here. If we go back to person, we're going to see that we have the first name and the last name. But in our player class, these member variables are going to be inherited because a player is inheriting from a person. This is the syntax to do that. But even if the player class has a person part inside of it, we can't really access private members from person from a player object. We're going to see a few ways we can get around this. And one of those is to go public methods from the person class to access private parts of the person class. This is going to give us access to these member variables. If you go down in our stream output operator, you're going to see that we are using these getters here. The parameter is a player object that we want to print out. But to get access to the names, we are getting the first name and the last name through our getters here. Before we really explore this any further, I think it is a good idea to go in the main CPP file and create a player object. So we're going to do that. We're going to say P1 and we're going to specify that they play basketball. Why not? Okay, so we have our player object. And we can really do all we want with it. For example, we can print the information about this player object. If you remember, in player, we have a stream output operator, which is going to print all the information. And here we have a problem because this guy is taking the data by reference. And this is not a reference. This is a temporary object that we are passing here. So we could go back and change this to take a string view parameter. Let's go back and do that. We're going to include a string view here in player, and we're going to change our parameter to be std string view by value. And we're going to do that in the CPP file. Let's do that. We're going to say std string view, and this should take care of our problem here. You see that the problem goes away. Now that we have this guy, we can print it out. We can say std out player and put the information out. Okay, so now that we have this, we can try and build our program. We're going to use GCC, our favorite compiler, and you're going to see that we have a problem, undefined reference to player destructor. Let's go back in the header and see that we have a destructor, but we probably didn't put a destructor in the CPP file. So let's do that. Or because we're not doing any dynamic memory allocation, we can even completely take out this destructor, and we're just going to use the one the compiler generates for us. This is going to be much easier to handle in our code. So we can build again with GCC. Okay, the build is good. We can run this program. And let's see if we have a PowerShell window. We don't. We're going to bring up a new one. and we're going to run Rooster, we should see information about our player. So player, the game is basketball, the names are mysterious person, because that's the default data we inherit from person. If you go back to person, you're going to see that the default data in first name is mysterious, the default data in last name is person, and it is what we see printed out here in our PowerShell window when we print information about our player object. Another thing I want you to see is that we can actually really prove that any player object is going to have a person part of it baked in. And that's going to be storing the information that is modeled into our person class. And we can use a debugger to do that. For this to work, I am going to put a breakpoint here on line 8, which is printing things out. This breakpoint is going to be hit after our object is set up, and we can really see the data inside this guy here. So what we're going to do, we're going to hit this run tab, and we're going to use G++. We're going to use the debugging tools that come with GCC, because this is our favorite. We're going to hit the green button here. This is going to start our debugging session. A binary is going to be built and it is going to be plugged into our debugger, and we're going to hit our breakpoint here. Now, if you look on the left here, you're going to see a title that says locals. We're going to expand this and we're going to see that the P1 object actually has a person part of it. And you see that Visual Studio Code is being helpful here. It is saying that this is the base class. And if we expand, we're going to see that we have our member variables. We have first name and last name, and this is a player object that we are looking at. Don't forget that. And on top of our person part, we also have our own member variable, which is the game that we play, and it is right here. Hopefully this proves to you that any derived class object is going to have a base part embedded into it, and that's going to be the foundation on top of which the derived class is going to be building its own thing. This is the basic idea here. Okay, now that you've seen this, we're going to kill our debug session, and we're going to see some of the things you need to be careful about when doing public inheritance like we are doing here. The first thing I want you to see is that you don't have access to private parts of the base class. If you go back to person here, let's kill this so that you're not confused. If we go back to our person class, we're going to see that our first name and last name are private. So they won't be accessible to any class that does public inheritance like we are doing here. They are just going to be private. They are going to be part of the class, but the derived class won't have access to them. This is the idea here. And if we go in our output stream operator and comment out what we have here and try to directly access these member variables, let's do that. I am going to copy the code here and put that on top. And we are not going to go through the getter methods from the base class. We are going to try and access mFirstName. Let's go back and look at the names for the member variables. It is first name and last name. Let's use that. We're going to say first name. You see that through IntelliSense, but trying to access that is going to give us squiggly lines. You see that we have this in our autocomplete, but we have squiggly lines. We can't access these. If we try to compile our program, let's do that again. We're going to use GCC and we are going to get compiler errors, and the compiler errors are basically going to say first name is private within this context. Again, the meaning is that first name is private to the base class and we have no business accessing that in a derived class, which is the player class here. This is the meaning. So we can't really access that. Okay, I realize this is a global function, but even if we try to do that from a member function, let's do that from a constructor. We're going to try and say first name. Okay, I realize the access we are trying to do from the output stream operator is really not a good example because this is not a member function. It is a global freestanding function. So we can try and change the first name and last name from the constructor, for example, and we're going to see that this is not going to work either. So we can take this out and we're going to remove our block comment. So we're going to take out what we just did here, and we're going to uncomment our good code here, which is using getter member functions from the base class. And we're going to try and change the first name and last name from the base class and change those into our constructor of the derived class. We're going to try and change, for example, the first name and make it John. And we're going to take the last name and change that to Snow. Let's do that. And let's go back and make sure we have the correct names. And you see that we have squiggly lines. We can't really do this because these are private members of the base class and we can't access them from a derived class. They are part of the player class, which is a derived class, but we don't have access to them. We can't modify them or do anything. We can't read from them. We can't write from them. This is the message here. If we try to build our program, we're going to use GCC to do that. We are going to get compiler errors, and let's see the compiler error we get. Again, the error is that first name and last name are private to the base class, and we have no business accessing them from a derived class like we have here. So if you need any kind of access to a private member of the base class, you will have to go through something that is public. And a good example is getter methods, which are going to allow you to change things. So for example, if we want the ability to change the first name and the last name, we can set up a bunch of setter methods. Let's do that. We're going to say setters, and we're going to say void set first name, and we are going to pass an std string view. Let's do that. We're going to say string view here, fn for first name. This is going to modify our class, so we are not going to mark this as a const member function, and we're going to say first name equals fn. This is going to do. We are going to set up a setter for the last name set, and we're going to pass a string view here, and we're going to say ln for the last name. Again, this is not going to be a const member function, so we're going to say last name, and we can pass in ln as our new name here. Now that we have these in, we can take out these things we have in the constructor. I think the job for this is done, and this is going to give you compiler errors. And we can go in our main CPP file and change the names for this person here. For example, we can say P1 set first name. We're going to pass John, and we can also set the last name. We're going to say P1 set last name, and we're going to pass Snow. And this is going to do, if we build and run this program, we're going to see that the build is going to be good. This is the first step. And if we run, we should see the information printed out. We want Jon Snow printed out, and the game should be basketball. Let's clear and run Rooster. We're going to see that the data is in here. The names are Jon Snow, and we have our game to be basketball here. But notice these are base methods, and we are calling them from a derived object. And this is living proof that the public members from the base class are going to be inherited and usable from a derived class that does public inheritance like we are doing here. And this is really the main message. You can inherit publicly and have access to public stuff from the base class and use them in your derived class, but private data is going to still be private to the base class. You can't use that in a derived class. This is the message here. And this is really all I wanted you to see in this lecture. The big thing is to notice the syntax you use to do inheritance. And if you do this, the player class is going to be derived from person, and it will have a person part baked inside, and we can build on that foundation and, for example, put in our own member variables and do all kinds of crazy things. Public stuff from the base class are going to be inherited and usable from a derived class. We just saw that by setting up a bunch of setters that live in the public scope of the base class, and they were usable from the outside because they will be inherited as public in a derived class. So we can really call these methods and use them from the outside like we are doing here. But private data from the base class is not going to be accessible and usable from a derived class. And we saw that by setting up this piece of code in the constructor of player, this is going to give us a compiler error saying that first name and last name are private to the base class. We are going to stop here in this lecture. In the next one, we're going to learn about another kind of access specifier we have in C++, and that is protected. So go ahead and finish up here and meet me there.